Everybody, let's tackle question 10 now. This is a combination of an applied force and the frictional force produces a constant torque of 34 Newton per meter in a wheel rotating about a fixed axis. The applied force acts for 5 seconds. During this time, the angular speed of the wheel increases from 0 rad to 10 rad per second. The applied force is then removed and the wheel comes to a rest in 50 seconds. What is the torque of the applied force? Now in the book it says, I think it says what's the torque of the frictional force. Beautiful question because it's been modified and it's not like exactly like the book, but is it easy? Absolutely. I'm just gonna deal with it right now. All right, so the answer is A, and let's just see why it's A. But we're not going to focus on the answer, and even in an exam hole, I don't want you to be focusing on the answer. Just cover up the answer with a tissue or something you can cover it with, and just deal with the question and not the answer. Okay, let's just deal with it. It says that the torque applied by the applied force and plus the torque applied by the frictional force, they produce 34 Newton per meter. Now, it then says that the applied force acts for 5 seconds. So for 5 seconds, okay, we have the torque by the applied force plus the torque by the frictional force, which is then 34 Newton per meter. Only for 5 seconds. Only for 5 seconds. All right. Now, what I want you to do is I want you to write torque in moment of inertia times angular acceleration. Just deal with that, but let me just draw it, guys. So torque is I alpha. All right. Why did I deal with this? It clearly talks about angular acceleration, so I'm not going to use torque equals to FD, okay? And since it says the net torque, the constant, the combination of both of them, so I don't know if you remember, but in the book, it says torque net. Torque net. Okay? Torque net equals to moment of inertia times angular acceleration. Now, we can find angular acceleration twice, and we will find it twice. But the reason why I'm going to only deal with this, well, let me just find for both of them, okay? It says that it goes from 0 rad to 10 rad. That means that the final is 10. I'm not going to even write the initial. And it says for 5 seconds. So that's going to be over 5, and that's going to be 2 rad per second squared, okay? So it's 2 rad per second squared, okay? The other alpha that I can find, that I will find, is it says that okay, the applied force is then removed, okay? The wheel comes to a rest. That means that the final is now 0 and the initial was 10 rad, okay? So that would be negative 10 over 50. The zeros cancel out each other, and we know that negative 1 over 5, though, that would be negative 0.2 rad per second squared. Guys, now this is something that I would like to focus on. Why did I use this one and not this one? Why did I use this one? Well, if you go and look at it, it says that the applied force acts for 5 seconds. It is within this 5 seconds where the combination of both torques equals to 34 Newton per meter. And it's only through that duration I can find the torque of the applied force. I cannot use the alpha equal to negative 0.2 because that is purely frictional, the torque applied by the frictional force. I cannot use that because I don't have applied force. It says my applied force is removed when in that 50 second. I can only use that 5 seconds where I have both of them, okay? So that is where that is exactly the alpha of, the net. So 34 equals 30, 34 equals I don't know what I is, moment of inertia, times 2. Okay, now solve for I is equal to 17 kilogram meter squared. Okay, now I found the I. Okay, now I found the I don't have the I gotta find it. Okay, all right, and then I move on to finding the frictional, the torque by the frictional force. And the reason I'm going to do that is because I look at this. Okay, before that I had two, well now, up until now, I have two unknown. This is an unknown as well as this one, and if I want to find this one, I have to find this. I cannot find something when everything is unknown, right? This is just purely like common sense. I cannot go into that without not knowing something else, right? So I have to find the torque by the frictional force in order to be able to find the torque by the applied force. That's just how it works, not my fault. So now the let me delete this one sec. Okay, I'm going to use this, but all right. Now let's get into finding the torque by the frictional force. Okay. The torque, copy. The torque by the frictional force equals, again, moment of inertia times alpha. Now, the reason why I'm going to be using this alpha, this angular acceleration, is because it says the moment the applied force is then removed, then we purely just have the torque by the frictional force. No difficulties in finding the torque by the frictional force whatsoever. So I have the moment of inertia. My moment of inertia is constant for an object that doesn't change. So unless it's stated that it changes, otherwise stays constant. So we have 17 times negative 0.2, negative 3.4 Newton dot meter. This is torque by the frictional force. Now we go back to this. Okay, copy. And now I want to find the torque (34) minus and let's find it. So that be equals to 34 minus 3.4 37.4 Newton dot meter. And there you go, you got the answer, and it is A. I love this. I love these two questions. I loved them, but whatever. Anyways, that's it. That's it for this video. I hope you guys learned something, and if you guys have any question by any chance, just drop it in the comment section below, and inshallah I will do my very best to answer you guys. Bye.